15th part x raised to the power minus 100. Solution: let y is equal to x raised to the power minus 100. Just start our differentiation process. Y plus delta y is equal to x plus delta x raised to the power minus 100. Again containing a power with a negative integer. So delta y is equal to x into 1 plus delta x over x raised to the power minus 100 minus y. This minus 100 will become a power of both of these two terms, x raised to the power minus 100 and 1 plus delta x over x raised to the power minus 100 minus the value of y, which is x raised to the power minus 100. And delta y, by taking x raised to the power minus 100 as a common factor from both these two terms, we have 1 plus delta x over x raised to the power minus 100 minus 1. Applying binomial series here, delta y is equal to x raised to the power minus 100 and 1 plus nx, n is minus 100 and x is delta x over x, plus n into n minus 1 2 factorial, 100 into minus 100 minus 1 2 factorial, and delta x over x whole square up to so on, minus 1. So you must note again this step, that in this particular thing we have a negative integer as a power, so that will become an infinite series. So we will not write end term here because of this negative integer as a power. And in the previous part we have a power with a positive integer, which is x raised to the power 40. Due to that positive integer, we have written an end term, delta x over x. But if this power is not a positive integer, rather that is a negative integer or a fraction, we will not write an end term, and that will become an infinite series. This 1 and minus 1 will be cancelled out, and delta y is equal to x raised to the power minus 100 delta x over x as a common factor, and the remaining portion will be minus 100 plus minus 100 minus 100 minus 1 divided by 2 factorial x, which is delta x over x, and up to so on, infinite number of terms. Now dividing both sides by delta x, so delta y over delta x over delta x, x raised to the power 1 plus 100, combining power due to the same base, and the bracket portion will remain same. After cancelling this delta x, we have delta y by delta x is equal to 1 over x raised to the power 101, and the bracket portion will remain same. Applying limit on both sides, delta x approaches to 0. We have limit delta x approaches to 0 delta y by delta x, and on right hand side limit delta x approaches to 0 1 over x raised to the power 101. The bracket portion again the same thing. Left side will become dy by dx, and on right side after applying limit we have only this first term, which is minus 100, multiplying by 1 over x raised to the power 101, we have minus 100 x raised to the power 101. So finally the derivative of the given function, which was x raised to the power minus 100, will become minus 100 into x raised to the power 101. Question number 2. Find dy by dx from first principles if the first part is square root x plus 2. Let me start our solution. We have y is equal to x plus 2 square root, and we can write it as y is equal to x plus 2 raised to the power 1 by 2, and you can easily know that this will become a same thing which we already simplifying or already calculated differentiation of such type of functions like x plus a raised to the power x plus 4 raised to the power some integer, some fraction, some negative integer in our question number 1. So that will become a same thing. Applying differentiation process, we have y plus delta y is equal to x plus delta x plus 2 raised to the power 1 by 2, and delta y will become x plus 2 plus delta x raised to the power 1 by 2 minus y. Taking a common x plus 2 we have 1 plus delta x over x plus 2 whole raised to the power 1 by 2, and applying or putting the value of y, x plus 2 raised to the power 1 by 2. Now x plus 2 will become a common factor from these two terms. We have x plus 2 raised to the power 1 by 2 and 1. By taking common x plus 2 raised to the power 1 by 2, we have 1 plus delta x over x plus 2 raised to the power 1 by 2 minus 1. We can apply binomial series here. Delta y is equal to x plus 2 raised to the power 1 by 2 and 1 plus nx. N is 1 by 2 and x is delta x over x plus 2 plus n into n minus 1 2 factorial x square, where x is delta x over x plus 2 up to so on. Again, the power is 1 by 2, which is a fraction, so that will become an infinite series, and this minus 1 will remain same at the end. Now 1 and minus 1 will be cancelled out. We have delta y is equal to x plus 2 1 by 2, and taking delta x over x plus 2 as a common factor, we have only 1 by 2 plus 1 by 2 1 by 2 minus 1 2 factorial and delta x over x plus 2 up to so on. Dividing both sides by delta x, so delta y over delta x is equal to delta x over delta x. X plus 2 as a common base, power will be combined 1 minus 1 by 2, and the bracket portion will remain same. So delta y by delta x is equal to, after cancelling this delta x, we have 1 over x plus 2 raised to the power 1 by 2. Simplifying this 1 minus 1 by 2, and this one is the same portion. Now taking limit on both sides, delta x approaches to 0. Limit delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0, 1 over, this can be written as in the form of square root x plus 2 square root, because this one is a power which is 1 by 2. 1 by 2 plus 1 by 2 minus 1 2 factorial and delta x over x plus 2 and up to so on. Left side will become dy by dx after applying limit. Sorry, this one is actually dy by dx, not delta y by delta x, because this one is the notation of dy by dx. And on right side, when we apply limit, all the terms will become 0 except this first term, which is 1 by 2 into square root x plus 2. And just put the value of y, which is x plus 2 square root. We have 1 over 2 x plus 2 as the differentiation of this given function. The second part, 1 over square root x plus a, almost the same part, just simple and small change, x plus a instead of x plus 2 in the previous part. So y is equal to 1 over x plus a square root, and y is equal to x plus a raised to the power minus 1 by 2. Applying the same process of differentiation, we have delta y is equal to x plus a 1 plus delta x over x plus a whole raised to the power minus 1 by 2 minus x plus a raised to the power minus 1 by 2. Just replacing 2 by a and power 1 by 2 by minus 1 by 2, we will get result of this part 2, which we already simplify in our part 1. So delta y is equal to x plus a raised to the power minus 1 by 2 as a common factor from these two terms, 1 plus delta x over x plus a raised to the power minus 1 by 2 minus 1. Now apply the binomial series here. We have this one, and this 1 and minus 1 will be cancelled out. So delta y is equal to x plus a raised to the power minus 1 by 2, the same step. So delta y is equal to x plus a raised to the power minus 1 by 2, and delta x over x plus a will become a common factor. We have only minus 1 by 2, minus 1 by 2, minus 1. This one is actually minus 1 by 2. Minus 1 2 factorial delta x over x plus a up to so on. Dividing both sides by delta x, delta y by delta x by delta x, x plus a, combining these two powers because of same base. Sorry, this one is not x. So x plus a raised to the power 1 plus 1 by 2. This bracket portion will remain same. After cancelling this delta x, we have delta y by delta x is equal to 1 over x plus a raised to the power 3 by 2, and in the bracket portion that is remain same. Taking limit delta x approaches to 0, limit delta x approaches to 0, delta y by delta x and applying limit also on the right hand side. So dy, left side will become dy by dx is equal to, after applying limit delta x approaches to 0, all the terms will become 0 except this first term, which is minus 1 by 2 multiplying to 1 over x plus a raised to by 3 by 2 will become a differentiation of the given function, which is actually 1 over x plus a square root, and right side will represent the derivative of this function, which is minus 1 by 2 x plus a raised to the power 3 by 2.